So today we have a very beautiful geometrical question. The beauty of this question you can see on the screen. There's a circle placed inside a square, and from the three corners of this square you draw three tangents to this circle. The length of the tangents are 3, 7 and 8, and also the side of the square is given, that is equals to 10. All you have to do is find the radius of the circle. So let us see the solution. So first of all, the first data we can utilize is that these three lines are the tangent lines. So at the point of contact, the radius and these points will be perpendicular. So let this be the center of the circle. Therefore, from the center to this point, it's going to be 90 degree over there. From the center to this, it's going to be 90 degree over here. Note that yes, this is not a straight line, it's a broken line, like this and like that. Here it's coincidentally looking like a straight line, but it's not. And similarly from the center to that, it's going to be 90 degrees, so marking it nicely over there. So yes, 90 degree over there. So 390 degrees we have just formed. Now what can we do next is that I'm just thinking to join from the vertex to the center of the circle. So from the vertex of this square to the center of the circle, this is the straight line. Similarly for this tangent also, so from here to the center, let it be clear, yes, so from here to the center, and similarly for this 3 1, so from corner to the center. Now let the radius that we have to find is equals to x, so this length is equals to x, this is also the radius, so x, and that is also radius, so it is also equals to x. Now look in this particular right angle triangle. Yes, it's the right angle triangle because of this 90 degree. Its base is 3, its side length is 7, so the hypotenuse becomes square root of squares of addition of this both according to the Pythagoras theorem. So the hypotenuse, that is this length, becomes square root of 7 square 49 plus the base square, that is x square. Now look in this right angle triangle, the base 90 degree because of this, the base is x, the side that is of the yellow color is 8. So the hypotenuse, that is this length according to the Pythagoras theorem, becomes square root of 64 plus x square. Now this third one, the base is equals to x, the side that is of the blue color is equals to 3. Therefore the hypotenuse becomes square root of 3 square 9 plus x square. Yes, so in this particular case we are just having something like that. I'm just taking out the things that we need. So doing that clearly over there. So this is the side of the square, this is the top side, and let this be the diagonal. So I'm just marking that the diagonal which I'm taking with a different color. So diagonal, that is from this point to this point in this diagram. Similar diagram, or we can say similar diagonal, I want to take over here. So I'm taking that over here. I'm just taking this kind of color because you can just figure out it very quickly. Yes, now this is the center of this circle, and let me name the diagram first of all. So from here A, that B, the center of this circle equals to O, and let this be equals to C. So what I have taken out is first of all the triangle, that is A, C and B. So I am writing like A, B and C. This is the center somewhere over here, and its point is equals to O. From B to O I have joined a length, and that is having a length 9, square root of 49 plus x square. AO is having a length, that is square root of 9 plus x square, and CO is having a length, that is square root of 64 plus x square. And instead of O, let it be equals to Q. There's no reason, I'm just taking it as Q. And here also Q, because pronouncing AO and pronouncing AQ sounds better. So here also Q. So this is the thing I have just taken out, and these three white lines are having a very nice length, that is square root of 49 plus x square. This is having a length, that is square, let it be clear, yes, it's having a length square root of 9 plus x square. And CQ is having a length, that is square root of 64 plus x square, so 64 plus x square. This is the side length of the square equals to 10, that is the side length of the square equals to 10. Okay, let this be angle equals to alpha, let that angle be equals to beta, and this is a complete 90 degree, remember, because it is the corner of the square. So at A it is the corner of the square, so it's going to be complete 90 degree. Now what I'm going to do is take the cosine rule. According to the cosine rule, I will find the value of cos alpha over there, cos beta over there, and as we can see, there's a relation that alpha plus beta equals to 90 degree. These three things combined together can give me the value of x. So finding the value of cos alpha in this particular triangle. So first of all, let us discuss what is a cosine rule. If there is a nice triangle, no matter what any kind of specification, just a triangle A, B and C, the side lengths are P, Q and R, and any of the angle, let this be equals to theta. Then the value of cos theta is always equals to square of the adjacents added together. So P square plus R square minus the square of the opposite. So opposite to this particular angle theta, so opposite to theta is Q, so minus Q square upon 2 times the product of adjacents. So adjacent sides are P and R, So P and R. So according to the cosine rule, in any triangle, the value of cos theta is this thing. We say it like cos theta is equals to square of the adjacents added together minus the square of the opposite upon 2 times the product of adjacents. So I'm going to use this to find the value of cos alpha in this triangle, that is triangle AQC. So I'm writing it like that with triangle AQC. In this particular triangle, the value of cos of alpha. So cos of alpha is going to be tan square plus square root of, so I'm just writing the simplifications also. So this is the alpha, so the adjacent sides are this tan and square root of 9 plus x square. So I have to add their squares. So tan square is 100, square root of 9 plus x square whole square becomes 9 plus x square minus the square of the opposite. So opposite side to the alpha is this one, that is square root of 64 plus x square. So square root of 64 plus x square, the whole square becomes 64 plus x square, and as there is a negative sign outside this bracket, so I have to just change the sign also. So over there it becomes 64 minus x square, and in the denominator 2 times the product of adjacent, so adjacent sides are 10 and square root of 9 plus x square. Okay, so plus x square minus x square got cancelled out. 100 plus 9, 109, 109 minus 64 is 45. So 45 upon 2 into 10, 20. So 45 upon 20 gives me 9 upon 4. So ultimately the value of cos alpha becomes 9 upon 4 times square root of 9 plus x square. So writing it clearly, so 9 plus x square. This is the value of cos of alpha. Remember, yes, is the cos alpha over there, and this is the value which we have got. Now similarly we will find the value of cos beta in this particular triangle. The triangle now we have is triangle AQB. So AQB, in this again by the cosine rule, the value of cos of beta is equals to square of the adjacents added together, so 9 plus x square and 10 square. So 9 plus x square, square root of 9 plus x square, the whole square becomes 9 plus x square minus, plus the adjacent square, that is 10 square, that's 100, minus the opposite square, so opposite is square root of 49 plus x square. So according to the minus sign and the square, it becomes minus 49 minus x square, and upon 2 times the product of adjacent, so 2 times square root of 9 plus x square, and the adjacent side is 10. These are the two adjacent sides. So in this positive x square, negative x square got cancelled out. Negative 49, positive 9 becomes negative 40. 100 minus 40 becomes 60, and in the denominator we have 2 into 10, 20. So 60 upon 20 gives me 3. Yes, so 3 upon square root of 9 plus x square is the value of cos of beta. So yes, this is the value of cos of beta over there. So I'm writing it over here. This is the value of cos of beta, and here we were having the value of cos of alpha. Now remember the relation I was telling, that alpha plus beta equals to 90 degrees. So let us utilize that. So I am having from this diagram that alpha plus beta equals to 90 degree. So from here I can have that alpha is equals to 90 minus beta. I can take cos on both the sides. So cos of alpha is equals to cos of 90 minus beta, that is equals to sine beta. So we have this relation that cos of alpha is equals to sine of beta. And this we have the value of cos of alpha from here, that cos of alpha is equals to 9 upon 4 square root of 9 plus x square. So putting that over here, so cos alpha is 9 upon 4 square root of 9 plus x square, and that is equals to sine beta. So now we need the value of sine of beta, and we already have the value of cos of beta, so we can have the value of sine of beta. Remember that sine square theta, or we can say sine square beta plus cos square beta is equals to 1 universal identity. So from here I can have that value of sine of beta is square root of 1 minus cos square beta. I have the value of cos of beta, I can put that over there as a square, so that is equals to square root of 1 minus cos square beta. So 3 upon square root of 9 plus x square, the whole square becomes 9 upon 9 plus x square. So this gives me square root of 9 plus x square minus 9 upon square root of, not square root of, only single times, so it means without any radicals, 9 plus x square. So the value of sine of beta I get is plus 9, negative 9 got cancelled out. The square root goes with the numerator and with the denominator. So when it goes with the numerator, it becomes square root of x square, that is x, and the denominator becomes square root of 9 plus x square. So this is the value of sine of beta. Now we can put that value over there. So sine of beta is having a value that is x upon square root of 9 plus x square. Now from this both sides you can clearly see that something is going to be cancelled, and that is square root of 9 plus x square, square root of 9 plus x square. So what remains is only single times x, and that is equals to 9 upon 4, and that's our answer. That value of x that is considered as the radius of this circle is equals to 9 upon 4, and that will be closely related, like we can have the decimal value, it will be something 2.25 2.25 we can say. Yes, 2.25. Not approximately, it's the exact value because the denominator equals to 4. It's the exact value, that is 2.25. So x is equals to 9 upon 4, or else we can say 2.25 unit. Here no unit was given, we can say unit. So this is the answer to the question, that the radius of this circle is equals to 9 upon 4 or else 2.25. So this was my method to solve this particular question. If you have any other method other than this, you can do comment below, or else you can DM me on my Instagram. And someone gives a better solution to the same question and we can show it to our viewers. It's best knowledge.